This is question 16 from exercise 1.8 in New Concise Project Maths 3b. We have to verify that 1 minus 2i is a root of z squared minus 2z plus 5 is equal to 0. And we have to find the other root. There's a couple of different ways we can go about doing this, but the easiest way we can do it to start with is we can substitute our root in, so 1 minus 2i into our equation in place of z. And if it is a root, then it will satisfy the equation. So we will get 0 on the left to match our 0 on the right. So let's start with that. So if we go 1 minus 2i squared in place of our z squared, minus 2 times 1 minus 2i in place of our 2z, we still have our plus 5, and that is still equal to 0. So I'm just going to expand that out and see if it is in fact equal to 0. So 1 minus 2i all squared is going to be 1 squared plus 2 times 1 times minus 2i, and then plus minus 2i squared. And then we multiply our brackets here. Minus 2 times 1 is minus 2, and minus 2 times minus 2i is plus 4i, and we still have our plus 5 over here. So 1 squared is 1, 2 times 1 times minus 2i is minus 4i, and then minus 2i squared is going to be plus 4i squared. We still have our minus 2 plus 4i plus 5, and it's still equal to 0. So now it's going to total it up. We have a minus 4i and a plus 4i, so they are going to be equal to 0, so it's going to cancel each other out. And then number wise we have 1. 4i squared is, I squared is going to be minus 1, so 4i squared is going to be minus 4, so we're going to have 1 minus 4. And then we still have a minus 2, and then our plus 5. Well, 1 minus 4 is minus 3. Minus 3 minus 2 is minus 5, so we have minus 5 plus 5 equals 0. So we have 0 is equal to 0. So because this complex number 1 minus 2i has satisfied this equation, it means that it is definitely a root. And since it is a root, we can say for certain that the other root is going to be 1 plus 2i, because the roots always occur in conjugate pairs. So our roots for this are going to be z equals 1 minus 2i and z equals 1 plus 2i, like that. Now the alternative way of doing this, if we wanted, would be that we use the quadratic formula to solve out for the root, and we will find out whether this comes out as our root in the end. So the quadratic formula is x equals minus b plus or minus square root of b squared minus 4ac all over 2a. From our equation here, a is equal to 1, b is equal to minus 2, c is equal to 5. So if we put this into our equation, we're going to get z equals minus 2 plus or minus the square root of minus 2 squared minus 4 times 1 times 5 all over 2 times 1. I'm just going to tidy that up a little bit. So we're going to get z is equal to, so minus 2 is just 2. Minus 2 squared is 4. And then minus 4 times 1 times 5 is going to be minus 20. And that is still under a square root. This is all over 2. So we're going to get z is equal to 2 plus or minus the root of minus 16 all over 2. And then if we split that up, we get z equals 2 minus the root of minus 16 over 2. And z equals 2 plus the root of minus 16 all over 2. And the root of minus 16 is 4i. So this is going to be 2 minus 4i over 2, which is equal to 1 minus 2i. And over here, it's going to be 2 plus 4i all over 2. So we're going to get 2 plus. So we're going to get 1 plus 2i, which is exactly what we got in the example above, but just done a slightly different way. And that is that.